The contest awards $100,000 in scholarship prizes ranging from $1,000 to $20,000 to teams of high school juniors and seniors. Oh, maybe I'll make a point because I've got a lot of sophomores. You're a junior, aren't you? You're a junior. You're a senior. So we still want to look at that because we also have Sophia and Alice, and that would give you a team of 3 to 5. And Morgan. So I'll have to fuss at them for not being here, but they may have campus ministry, had to be somewhere else. Anyway, I don't even have to be with you. I just serve as your contact, and I register us, of which I already have done, just in case. But the older, you know, if we do it, the older people could share with us what happened and what they're doing. It helps students. Let's see, so what would you do? Anyway, I'll send out the information, so I'm just reading a piece of paper to you because that can be really aggravating. But you can look into it. We've got a while to decide. I think I've already registered us, and it didn't cost any money. So if we don't do it, we don't do it. But I wanted to get us in there. So that's one thing. And the younger students can be sort of looking ahead to that. Maybe we'll do that next year. Might as well try for some scholarship money and learn the ropes of that. Maybe one day soon we will even watch a 7-minute video of them working it. But next thing, I think that's it for now. I'm looking at some other contests that I can fill you in on. Now let's work some problems. We're going to start with the one that said the floor function, okay? There's something in Algebra 2 that I think that you probably learned called the greatest integer function. We hardly ever use it. We never comes up in calculus. It comes up a ton in real life. My older son's a computer programmer, and I can't even remember when he was programming in high school. Using the INT is actually how you type it in. You actually have an INT button on your calculator. We can go to math and go to INT. It's so valuable. It works like this. If I am in charge of the budget for the math team, and you don't have to donate money, but suppose I took up money to be part of the math team because we have to pay for our registration, which is not true, okay? But suppose that each contest costs $30 to register for, and I take all of our money that we've collected and divide it by 30, and I find out we have enough money to register for 5.6 contests this year. And can I do that? How many contests can I register for? 5. So do you see how it gives us, it's an awesome symbol. It tells you 2 things. It tells you you're not going to round conventionally, and it tells you you've got to pick an integer. So it's called the greatest integer function. You pick the when I surround this, the answer is 5. What's the answer to this? 5. What's the answer to this? 5. Okay. What's the answer to this? 4. Okay. However, there is something, so that's all I learned when I was your age, was the greatest integer function. As things have happened with certain businesses, or there's other things, that all of a sudden people pull this apart, and we also find a need for this, called the ceiling function. And you'll be glad, I'm having a hard time not finishing off that bracket just by habit, sorry. You'll be glad you heard this. So anyway, what if, like for instance, they want some people to volunteer for Gigi's Playhouse, like event that's coming up November 17th. And I'm not probably taking volunteers this year, but sometimes I have. And if I find out that I want to have 2 volunteers for every few people that enter the door so that we know we've got it covered, and I divide it out, and I find out I need 5.2 volunteers for the event, how many am I probably going to get? I'm probably going to get 6 to make sure I want to have enough. So there's somebody that is really not used very often has something called the ceiling function. Do you see how that tells you go up, not down? Okay? Like, oh, you better get some more if you can, all right? And so what happens, Kennedy, you were asking about the floor function, and unless somebody tells you, you'd never know what it's, a lot of times it's not even called that in a math book. Some do and some don't, but they pulled apart the greatest integer function. And so these 2 are actually the same question. Okay? In computer programming, which some of y'all will do, most of your programming language, if you use int of 4.8, it's going to say 4. So if you want the ceiling function, most people have to do an int plus 1 to force it to pick the higher one instead of the lower one. So int is going to always go floor. Okay? So that's what that was. You've seen it most likely. A lot of teachers call it the step function, but you've hardly used it except for in transformations. So most of you have probably, see if this sounds familiar to you. It's like closed, open. Anybody? No, yes, maybe. Okay. So let's see why it looks that way. Again, this is just worth our time right now, to learn. Because some people saw that and they're used to it and they just kept right on going in the problem, okay? So let's graph this, which means this by default, okay? So, I'm sorry, I thought of another example where people do this. If you find out that you're going to like an event and you need if you decided you're going to go buy tickets or something and you need $25.45, you're probably going to take $26 or $27 just to make sure, or $30, just to make sure you've got enough money. So how would we graph this? What is that? Well, I can't even get any, right? 0. What if I have enough to buy half of a computer or hire half of a person or register for half of a contest? I still don't have enough. I'm like, girls, we need more money, okay? So 1/2 is also 0. What about this? I go into Best Buy and I go, I have $900, so I'm going to buy the $1,000 television. They're going to go, no, you will not buy a television. What's that credit, which you shouldn't do. So I walk out of there with 0 televisions. They're like, come back when you save some more money. But as soon as I hit this, I'm so excited because I can go buy a television or I can go register for a contest. So at 1, all of a sudden it leaves here and lands at a closed circle there. What is 1.5? 1. What is 1.9? 1. So all from 1 to 2, you can only buy 1 computer or register for 1 contest. As soon as you hit 2, where's the dot? Is it at 2 or 1? All of a sudden, at 1.99, what are you still at? You're still at 1. Up until you just slam right into 2, and then it jumps up. Okay? So it's sort of like this. I wish I had a button I could push. It's like the line y equals x, okay? Where if I had a little button I could push and go ding, it's where all of these fractions just step by step fall down into the integer. Do y'all see what I mean? It's like that little slanted line goes, no, you don't have enough, bam. So it's sort of like that one, and fell down to an integer, down to an integer line. So that's how I worked the problem. If you could see their solution, sometimes I looked at their solutions and I'm so glad that I knew some of this because their solution's like this long. And then they had or, and I always work them before I look at their solution. They had or what I did, which went really fast. I'm not even going to show you the algebra yet. I like to see pictures, and this one asked us, I'll keep an eye on the time, and we'll end, to give you some time to get somewhere, because we'll do a couple of valuable things. Her little sister looks just like her. That's her little sister. That's not Grace. Let's see. Y'all are both such an interesting mix of your parents, too. It's interesting. All right, so I don't know which screenshot it is. I was just grabbing screenshots. Let's pick this one. All right, so not that one. So help me remember which one I picked. Let's see. Not that one. It's going to be the last one I picked. Oh, this one you would have had no idea. Yeah. But you will. Yeah, you will. Next year you'll know what that means. It's going to be the last one I pick. Mm-hmm. Oh, yeah, I could have done a preview. I guess y'all were thinking that while I'm sitting here doing this. Must be this one. There we go. Okay. So here we are. All right. So I looked at it like this. X squared over 2. And one thing that I do a lot as a pre-cal and calculus teacher is just preach that a picture's is worth 1,000 words, if you've ever seen that, heard that phrase. I wanted to carefully graph x squared over 2. And again, the algebraic explanation of this is treacherous. All right, so if I fill in x squared over 2, if I fill in 0, I get 0. If I fill in 1, I get 1/2. If I fill in 2, I get 2. Are y'all okay with that? Okay. Is that right? 2, I get 2. Okay. And negative 1/2, negative 1 is going to also give me 1/2. And negative 2 is going to also give me 2. So if you remember your algebra, or some of you are in transformations right now maybe, or maybe you're not. Who's done transformations like horizontal shrink and stretch? That was a horizontal shrink, okay? Like it took x squared that used to be 2 squared was 4, and you see it shrank it down to, I got the 0.22 instead of 2.4. That was a horizontal shrink, just a little math teacher in me. All right, now I'm going to graph this thing that you're like, what the heck is that, okay? So that's the greatest integer function, also known as the Flora function. So now we know that that looks like this. At 0, I get 0, and it goes out to 1. And then it jumps up to 1. I think white might be better. Starts at 0 and jumps out. As soon as I can buy one computer, I run to the store and buy one computer. As soon as I can get 2, I jump up here and go. And then I jump up here and go. And it also is coming from the negatives in the same fashion. And so how many are there? 1, 2, 3. And it doesn't look like they'll ever meet again. Did y'all see where they equal? Did y'all see what I was doing? I'm sorry, I didn't really explain that. I want to see where they intersect, so I like to see it. So I knew how to graph it. That's very helpful. And I didn't know if y'all knew that or not. It's usually in Algebra 2, so you might encounter it. Some of you might need Algebra 2 right now. But did y'all see it intersected it 3 times? And that integer function is going to keep going out that way, and we know the square is going to keep going up high. So that's how I got it. Okay? All right, so that also was great because you now know what the floor function is. And if they say ceiling, you go the other way. All right, let's do this one just for fun. You may have gotten this one because some people got 3 or 4 right. Okay, so my first instinct to this, quite honestly, was not to multiply it all out just as a math team coach, because I'm like, I'm not going to fall in that trap. So I actually started trying to do some fancy factoring I thought I was going to teach you. And then I thought, you know what, I think it's going to be okay to multiply this out. But always hold back, okay? One thing with math team is you want to look at groups of things and not plow away with your head like an Algebra 2 student. You want to kind of look at the big picture as you're moving through. So when I multiplied this out, I get, and by the way, I didn't try this, but sometimes it's good just to pick a number for n. I don't know what happened there, but that might work. Did you do that? Did it work? Did you get your answer right? Yeah, well, we could go back and check, but she may have just thrown in 3 for n and then figured it out that way. I did not try that, but that may be better than what I'm about to do. I usually will not do all that FOIL. I'll usually look like, I was wondering if there's a way I could treat this like ax squared plus b, plus c kind of thing, and I couldn't see of any way to factor this funny thing. So I'll show you that another day. Grace?
What I did was I chose 3 numbers, and then since there's 3 variables that we don't know, A, B, and C, I set up like a 3-variable.
Oh, okay, so you chose like 1 and 2 and 3. Well, 1 may not work because you get 0, but that might be great because you lose one of them.
4, 5, and 6.
Y'all see what she's saying? She did 4, 5, and 6, so she had 3 equations with A, B's, and C's in them. Please jump at that, like Susie? E? Susie, okay. Like Susie and Grace were talking about, okay? Jump at that, do it. They got it right, okay? So I like that way better, honestly. I like what these two girls have said better than what I'm about to show you. This would be like a last-ditch effort, and somebody might beat me to the answer, but this works. So does everybody understand before I go on what we mean about just pick some numbers for n and see what happens? Okay. If you FOIL this out, you get a times n squared minus 2n plus 1 plus bn squared plus c. Are y'all okay with where I am so far? Okay. Now I'm going to always refrain from doing too much multiplication, but I felt like I needed to go on if I was going to go this route. All right, so that gives me an squared minus 2an plus a plus bn squared plus cn squared plus 2cn plus c. And then I looked at the coefficient of n squared, which is 1. Do y'all see my n squares? So I felt like a plus b plus c had to give me 1 n squared. I mean, did y'all see I've got to add a n squared and b n squared and c n squared to equal 1 n squared. So then I went to 4n, and so my coefficients of n, negative 2a and 2c, had to equal 4. Did y'all see my coefficients of the n? They had to add up to be n. And then what would add up to be 4? The things without n's in them. So the constants a and c. So a and c also had to add up to 4. Very similar probably to what Grace ended up with, something, probably she got quicker to that point where she had a's, b's, and c's with numbers in them. So they kind of merged together. Now you can do elimination or substitution. I'm going to multiply this one by 2. So that's going to give me 2a plus 2c equals 8. I'm going to carry this one over. Negative 2a plus 2c equals 4. So I get 4c equals 12. So c is 3. And I'm not going to finish, but y'all see once I know c, then I can know a and I can know b. And again, I hardly ever would do all of that algebra. That's usually not math team. Math team's probably usually plugging in a number and seeing what happens. It's like off the beaten path kind of thing. I thought this was really going to go awry for me, and I was going to get stuck in some horrible loop. But so anyway, I did want to do it my way, that I did it yesterday. I got it right, and so so always make sure you answer the question a squared plus b squared plus c squared, and not just a plus b plus c or whatever. So that's also true of SATs. Always make sure you answer the question they ask, because they'll have that other one sitting there, multiple choice. You know those questions that like boys and girls went to the amusement park, and how many boys were there? But the problem's set up to where you find the number of girls, and you'll get girls is 5, and 5 will be sitting there. Make sure you answer the question that's being asked, or it can get kind of tricky. Any more comments on this one? Okay. Again, I like picking the number method better than what I just did there. All right, now let's go to this one. Let me see which one. I don't know, y'all can pick 1 or 2. Both of them are going to require some information. 2? All right, here we go. So today, probably all I'm going to get done, which again is why I videoed this, because some people really couldn't be here. And I know a couple of people that watched the video last time. You'll learn. And also the good thing about me making a video is you don't have to meet with me at a certain time and I go through all of this with you again. You could go, oh, well, that was 20 minutes long, and you could watch one problem and stop. Or you could fast forward to the problem that you didn't understand, or the one you wanted to know what radius energy, or you can just kind of skim through what we're doing. And skip if you understand something, but probably no one understood this problem, okay? And next class, if I don't get to it, in this class we'll do the probability problem, in which case there was this huge long thing, and yesterday that I looked at, and I tried, and I was listening, And so, like in probability, I went to Mr. Hill, and he did it in like 2 seconds. So I'll show you what he did there. I think a lot of you would think of what he did, but I tend to be too involved in probability problems, and a lot of times, again, you have to step back from them. But I'll always ask for other people's input as I'm coaching you. So here's how a base works. We used to teach bases in some classes. I don't know that I ever saw base 2. I think I did in my algebra class, but you know, people do binary a lot. Base 2, 1s and 0s.
They use stuff for coding.
For coding. So is that what you said? Yeah. And so almost all computer coding and things that you put in the computer is either on or it's off. And it's a 1 or a 0. Okay? That's base 2. So you have to be told what base you're in. And so if I said 1011 and I'm in base 2, that's not 1011. Okay? Now, what is this in base 10? 998. Okay? By default, I don't have to put the base if I'm in base 10, but maybe I hadn't thought about what base 10 really means. So y'all stop me if I'm doing too much. If you're like, okay, we know this, so just stop me. In base 10, we have the units. This is 10 to the 0. This is 10 to, sorry, I didn't want to write it there. These little boxes that my teacher taught me. This is 10 to the 0. This is 10 to the first. This is 10 to the second. This is 10 to the third. This is 10 to the fourth. So I had 8 1s, 9 10s, and 9 100s. I got 900, 9 times 10, 998. Do y'all see how that works? So let's do this in base 2. And again, for math team, if we continue going, which I fully believe we will because you got a great start, you'll be glad we did this, and you'll get used to it. And you'll know things other people don't know, or things that maybe your peers don't know. So anyway, if I'm in base 2, 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4, 2 to the third is 8. And so it works just like base 10, it's just that's probably the only one you ever worked in. Okay? So if I have 1 0 1 1, I can convert it to base 10. All right? So I have 1 1, I have 1 2, I have no 4s, and I have an 8. So if I wanted to convert that to base 10, it would be 11. If you went on Google and you Googled what 1 0 1 1 and base 2 equals in base 10, it would be 11. Okay? So let's do another base. Let's say if I had base 3. Oh, something I haven't shown you. Base 2 can only have the digits 0 and 1 in it. Because if I put 2 1s, I wouldn't put it there, would I? I don't need a 2. If I have 2 1s, then I have 1 2. Like in base 10, do you actually have the number 10? If you have 10 1s, you wouldn't put that there. You would have 1 10. Do y'all see what I mean? Okay. So base 3 is going to be comprised of what digits? 0, 1, and 2. Because if I have 3 1s, then I'm going to have a 3. Okay? So let's say that I have 221 in base 3. Okay? So I have 3 to the first, 3 to the 0, 3 to the first, 3 to the second. So you see it works just like base 10. And so I have 1, 2, 2, 1. What is that going to equal in base 10? I have 1, 1. How many 3s do I have? I have 2 3s, and so that's 6. And I have 2 9s, 18. And so what is that, 25? Okay? So how do bases work? If I'm in base 10 and I had 998, if I'm in base 10 and I have 998, that means 9 times 100 plus 9 times 10's digit plus 8 times the 1's digit. What did this one mean? 2 times the 9's place, 2 times the 3 place, and 1 times the 1 place. What did this one mean? Do you see what I'm doing?
Yeah.
Okay. So, if you had a number in base 3, that would mean, see how I can write it, 3 times A plus A. Let me put it in the little boxes. Okay? So this is base 3, 3 to the 0, 3 to the first. Wouldn't you have 1A and then 3 times A and you would add them together? All right, so if I have A, base 7, that if I put it in my little boxes, do y'all see that would be 7A plus A? How in the world you would have ever known that? You wouldn't. We just had to let that one go for now, but you'll see bases and you'll get it. But we'll work on them some more too. It can't be a one-shot thing, but when we encounter bases, we'll work on it. May have a whole day we just talk about, I find some math contest problems with bases in them. I think bases are really fun. I really like them. I don't know why we don't teach them very much because I guess there's not much use for them other than base 2. There's also the hexadecimal base system, if you've ever heard of that. It's based, some things are based on base 16. Okay, so now it said A, what did it say? There's a lot of talking. All right, so this top part was A times D plus A divided by A times C plus A equals A times B plus A. I know, did y'all grab that from everything I just did? That's why y'all are the ones sitting here in this room, because that would be like another 30 minutes sometimes with the whole classroom of people. I understand you might not remember that next time, but you might based on my explanation that that's what's going on. You've got the units, the lack of a better word, the tens, the hundreds, or the whatever the place is, okay? That also doesn't make this problem all that great, though. I'm going to cross multiply. I'm going to factor out an A and I have D plus 1 equals this side, which is A times B plus 1. I'm going to multiply because I don't want to divide. So that's A times C plus 1. That just made me happier. You could have kept it divided. I just made me feel better. What can you cancel out? A's. So, whoa, let me be careful. I felt like I should cancel out the A's, but can't. There's an A squared on one side. So did I just leave the A's in there when I worked it? I don't remember now. I was thinking I canceled out the A's. I hope I didn't. Let me look at my work. Can you give me that folded paper? Thank you. Let me see what I did. Okay. So, all right. So we had this. Sorry, it doesn't respond sometimes. And we'll quit in a minute and pick back up here later. All right, so I have A times D plus 1 equals, why did I leave the A there? I guess it doesn't matter where you leave the A, but it wouldn't be there. It would be, I'll write down what I had a second ago. A times D plus 1 equals A times C plus 1 equals A times B plus 1. Is that my letters kind of? Yeah. Okay. So now I have D plus 1 equals A times C plus 1 times B plus 1. Now A is, how do they define it? Well, I think it was an integer. Oh yeah, I have the problem over here. Forgot I pulled it in.
Appropriately large integer.
Yeah, what a crazy wording. Okay, let A be an appropriately large positive integer, and base C, D, B, C, and D be integers greater than 1. So we know B, C, and D are bigger than 1. And D is less than 100. What is the largest possible value of B plus C? And so I actually, and I can't remember why I did this, I actually just ignored the A, like I let A be 1. I can't remember why I did that. So I'll probably circle back to this later. Why did I let A be 1? Let me see. It made perfect sense to me when I did it. And let me remember what we're looking for. Somehow I reasoned out when I got rid of a couple of the A's that I could let A be 1 and still find the largest possible. Oh, I know. Okay. So A could be anything. But somehow y'all can help me think through whatever I was thinking. A could be any number, a positive number, whatever it said. And if I can make this as big as I can make it, I don't know, I can't remember why I let A be 1. Any ideas why I did that? I've just totally forgotten why I just went straight ahead after I thought, oh, A could be 1. Would it matter what A was? What if I have something like 12 equals 2 times 3 times 2, with A being 2?
I think maybe since 1 is the smallest number that it could be.
That would force the other ones to be as big as they could be? Because we're trying to get B and C to be the largest thing they could be. I don't remember why.
So because if A is bigger than like B and C, it would be smaller.
Yeah.
Because you're multiplying to like the same number as D. It's like A is like 1 is the smallest.
I think that's what I did. I went small, I think. It sounds good to me now. I was just working in a hospital waiting room. And I just went right on writing and it worked out. I don't know, it'll dawn on me. Sometimes that happens to me where I'm just thinking so fast through something. I think that's right, Libby. That one makes sense. Anyway, now what did I do? So we'll come back. We'll talk about this problem later. So this is so hard to explain not knowing basis. I started really high because it said less than or equal to 100, I think. So if I let D be 100, then this becomes, I'm going to ignore this for now because I did for some reason, I don't remember. This would be 101. And are there 2 integers I could multiply to get 101? 101 is prime. And so I couldn't even let D be 100. But you see, I'm trying to now, like you said, make it as big as I can make it. So we'll stop here after I do 99. If D is 99, this takes a lot of thought on this problem. Some people probably skipped it. If D is 99, this is 100. And these could be some integers, couldn't they? We'll pick up here next time. But that could be 4 and 25. What else could that be? 2 and 50. However, it couldn't be 2. The reason it couldn't be 2 is that would force C plus 1 to be 2, and there's no such thing as base 1. If it was base 1, what integers would you be using? A bunch of zeros. Okay, so anyway, that's a heads up. Let's go on and get to our...
10 and 10.
Oh, no, I'm not. I'm just now starting in on this problem. So next time we meet, we'll pick up on this problem. In the meantime, I may remember why I let A be 1. I'll figure that one out. Work at the probability problem and the geometry problem that was number 1 that it started with. And so anyway, just watch your emails like y'all are so good at doing. Okay?
You need to pull up that.
Yeah, I could tell, so I'm stopping.